All right, so for this section, we're going to talk about two different things. All right, we'll talk about when we are bisecting the sides of a triangle, so perpendicular bisectors of the sides of a triangle, and then we're going to talk about when we're bisecting the angles of a triangle, and there's multiple things that happen. All right, before we get started, it's going to be broken up in two different videos, but before we get started, we need to just discuss a few things about lines. So here I have one line, two lines, and three lines. When you have three or more lines that intersect, they are said to be concurrent. Right? So concurrent, if you say that three lines are concurrent, that means that the three lines will intersect. So when three or more lines intersect, they are concurrent. Now this here, where they all intersect, right, that's where all three lines intersect at the same point. That is said to be their point of concurrency. Right? So when we talk about three lines being concurrent, we know that that means that they all intersect at the same point, and then that point at which they intersect is their point of concurrency. All right, so that's the first thing we need to discuss before we start getting into this video. Now we're going to start talking about perpendicular bisectors of a triangle. All right, so the first thing in this section is when we have perpendicular bisectors on all of the sides of our triangles. Let me see if I can make this a little bit bigger. All right. So if you look here at the drawing, each one of these red segments that I'm now highlighting in blue are all the perpendicular bisectors of the sides of our triangles. And we know that because they tell us that they're all intersecting at 90 degrees and they intersect each of our sides at a right angle, right? So when we have perpendicular bisectors of the sides of a triangle, so when we're bisecting the sides of the triangle, so there we have three segments, we have three lines. And they all intersect at one point. So that means those three lines are concurrent. And that point of concurrency, P, so where the three perpendicular bisectors intersect. All right, one, it is called your circumcenter. And also, that distance is the same to each of our vertices. All right, so let me do this in different colors. So that distance from P to A is the same distance. I'll do that in 4 tick marks. From P to C. And it's the same distance from P to B. Right? So when we bisect the sides of our triangle, it's the same distance to all of our vertices. So that point of concurrency, where they all intersect, is the same distance to all three of our vertices. Right? And then there's a few characteristics that I want to talk about with the circumcenter. Right? Our circumcenter can appear in three different ways. If we have an acute triangle, so if we have an acute triangle, it is 100% all the time, every time, going to appear inside of your triangle. So when we have an acute triangle, the circumcenter will be inside. When we have a right triangle, 100% of the time, the circumcenter will fall on our hypotenuse. So it will always be on our hypotenuse. Right? So the circumcenter will always be on our hypotenuse. And when we have an obtuse triangle, the circumcenter will always appear on the outside of our figure. Right? This is good for when we go into our next example. It will be good to be able to identify where it's going to appear because it will help for us to solve. Right? So in acute, it's always on the inside. On our right triangle, it's always on. And then our obtuse, it's always on the outside. All right? And now we're going to do an example using this. All right. So here we're saying, what are the coordinates of the circumcenter? So we want to know where all of the perpendicular bisectors will all intersect and meet. Where is that point of concurrency? And it gives us 3 points, P, O, and S. So what we need to do for this is we need to graph this first. So when we graph these 3 points, we'll graph it in purple. It's 0, 6, so 1, 2, 3, 4, 5, 6. There's 1 point. It is 0, 0, and it is 4, 0. 1, 2, 3, 4. All right, after we plot the points, we will then draw a line connecting our points. All right, now, the reason why we talked about this slide here is if we look at this figure, we have a vertical line and a horizontal line. We know that that's going to intersect at 90 degrees. So when we look here, we know that we have a right triangle, which then means we know it's going to appear on our hypotenuse. So a really quick way that we can do this is we can, since we know it's going to be in the middle of our hypotenuse, because we know that we have to bisect each of our lines. So all we really need to do is the midpoint of our hypotenuse. So here we have point P, we have point O, and we have point S. So all we really need to do is find the midpoint of segment PS. Right? So first we're going to do that, and I'll show you the longer way. But the midpoint of segment PS is we add our x's together, so 0 plus 4, we divide it by 2. We add our y's together, so 6 plus 0, we divide by 2. So that means that that midpoint will be 4 divided by 2, or 2, and 6 divided by 2, or 3. So that means that this circumcenter will appear on 1, 2, 1, 2, 3. All right, so it'll appear right there. So we already know our answer. Let's just go through and show how that is. So if we want to find a perpendicular bisector to this segment PO, we would have to find a line that is perpendicular to it and right in the middle. So that means we would have to find the midpoint of segment PO. So it'll be 0 plus 0 divided by 2, and 6 plus 0 divided by 2. So our midpoint is at 0, 3. So we know that it's going to pass through the point here at 0, 1, 2, 3. And then since it is a vertical line, we know it's going to be a horizontal line. So there is our perpendicular bisector, where we can draw the two congruent lines, and then we can put the right angle. This other segment, OS, once again, we have a horizontal line, so we know our perpendicular line is going to be vertical. And then all we have to do then is find the midpoint, so that way we can bisect that segment OS. So the midpoint of OS will be 0 plus 0 divided by 2. The midpoint of OS will be 0 plus 4 divided by 2, and 0 plus 0 divided by 2. So that will be 2, 0. So we know that our midpoint is here, so that's where our perpendicular bisector would have to go. We know it's going to have to be a vertical line, because if it's horizontal, the only perpendicular line that can go through there is a vertical. So we know that's its perpendicular bisector. And then therefore, where those two intersect, the third one would have to intersect as well. So you don't have to go ahead and solve anymore. So we know that is our answer. All right. Now, we're going to do this video a little bit different. Rather than me going through every example, now I'm going to end our videos where there's a question that you have to solve, and now you're going to have to send me the answer. So I want everyone to send me an answer on Remind of what the answer of the next question is. All right, so I want you guys to take a look at this question here, and I want you guys to try and solve it. All right, and then you guys are going to send me all your answers on Remind, and this is how we'll start each of our classes. Now we'll start by going over the problems that I have you guys hand in. All right, so this is the end of this video. You guys are going to do this problem on your own, and then send me the answer on Remind, and then we'll go from there.